Alright, in this video I'm going to talk about solving equations involving rational exponents. So again, all a rational exponent is just, well, where you have a fractional exponent basically. So suppose I want to solve x to the 1/4 equal to 3. Just like with a normal linear equation, you want to get it down to x to the first power. I'm going to do the same thing on this one. And the way I'm going to do that is you can raise both sides to the 4th power. Because remember, if you have things in parentheses, you multiply them. 1/4 times 4 is going to give me x to the first. 3 to the 4th, remember this is an exponent. You have 3 times 3 times 3 times 3, which is going to give us x equals 81 as our solution. Suppose we have 2x to the 1/3 minus 5 equals 1. I'm going to use the same idea on this one. The first thing I'll do is add 5 to both sides and get 2x to the 1/3 equals 6. The next thing I'm going to do is simply divide both sides by 2. That'll give me x to the 1/3 equals 3. And now, just like before, to get rid of the 1/3 power, I'm going to cube the left side this time, and I'm going to cube the right side. Well, 1/3 times 3 is x to the first. 3 cubed is going to be 27 as our solution. Suppose instead we have x to the 2/3 equals 16. Well, again, I want to get something so that I have x to the first power, so I'm going to use the same idea as before. Well, 2/3 times what is 1? Well, I believe 2/3 times 3/2 is going to give us 1. So on the left, I'm simply going to have x to the first power, and now I have to evaluate 16 to the 3/2 power. But I can write 16 to the 3/2 as 16 to the 1/2 raised to the 3rd power, because remember, again, it's in parentheses, so 1/2 times 3 will give me 3/2. But 16 to the 1/2 is the same thing as the square root of 16. The square root of 16 is 4. And 4 cubed, 4 times 4 is 16, times another 4 is 64. That will be our solution in this case. Let's do maybe 2 more here. Suppose we have 2 times x to the 1/5 minus 2 equals 0. Whoops. So the first thing I'm going to do on this one, a couple different ways you can do it. I'm just going to simply start off by dividing both sides by 2. So if you divide on the left side by 2, those will cancel out. Well, 0 over 2 is just 0. And I'll have x to the 1/5 minus 2 equals 0. I'll add the 2 to both sides. And just like the first couple problems, I've got x to the 1/5. To make that to the first power, I'll raise it to the 5th power, to the 5th power. On the left, I'll get x to the first. 2 to the 5th, I believe, you can check my arithmetic here, should be 32. 2 times 2 times 2 times 2 times 2 will give you 32. So let's do one last, maybe kind of trickier problem now involving these rational exponents. Suppose we want to solve 3n to the -2nd minus 19n to the -1st plus 20 equals 0. Okay, so they're not fractions, but a whole number is a fraction too, so this still qualifies. Notice if this negative wasn't here and the negative wasn't there in the middle term, this would simply be a quadratic equation. And we're actually going to use that on this trick to help us solve it. The first thing I'm going to do, so only the n is being raised to the negative second power. I can write that as 1 over n squared minus 19. I can write n to the negative first as 1 over n plus 20 equal to 0. And if you think about 1 over n squared, I can actually write that as 1 over n quantity squared minus 19 times, well, 1 over n to the first power plus 20 equals 0. And now what I'm going to do is I'm going to make it look just like a quadratic by substituting in x equals 1 over n. Okay, so if I substitute that in, I'm going to get the equation 3x squared minus 19x plus 20 equals 0. So now it does look like a quadratic equation. And I believe this is going to factor. Let's see, how would this factor? I think if we put negative 4 here and negative 5 there, because notice if I multiply it out, I'll get 3x squared, negative 15x, negative 4x, which is negative 19x, plus 20 equals 0. So now we'll simply set each piece equal to 0. So I'll have 3x minus 4 equals to 0. So if I add 4 and divide by 3, I'll get x equals 3/4. If I do the same thing with the other, I'll get x minus 5 equals 0. If I add 5 to both sides, I'll simply get x equals 5. And now, okay, our original problem didn't involve x. It involved, remember, n's. Well, we know, though, that x is equivalent to 1 over n, so I'm just going to plug that back in. I'll plug in the fact that 1 over n equals 4/3. And now you can simply just flip the fraction on the left or cross multiply, all kinds of ways. You'll get that n equals 3/4 is a solution. And likewise on the right side we'll plug in that 1 over n equals 5. And if I solve this for n, I'll multiply by n, divide by 5, I'll get that n equals 1/5 will be my other solution. Okay, so something a little trickier on this one. And this is actually a really common trick in mathematics in general. You've got a new problem, what do? You try to turn it into a problem that you're already familiar with and you know how to solve. In this case, we turned this problem involving negative exponents into a quadratic equation that usually most people will have encountered before they start doing these types of problems anyway. So we've turned a problem that was a little different into a problem that was hopefully a little more familiar, and use that technique. And that's what you want to do. You don't want to come up with a new way every time you have a problem. If you can just tweak it a little bit and put it in terms of another problem that you know how to do, that's always a good way to go. So I hope these few examples help. Again, they're not exhaustive, but just to give you a little idea of what's going on. If you have any questions, feel free to send me an email, preferably through my YouTube account. Also feel free to take a look at my website. I've got tons of videos there. If there's a specific problem you would like to see done, just let me know and I'll be happy to get to it as soon as I can.